Hey friends, we are still in chapter 8 and we are looking at factoring quadratic equations. That's our title for the chapter, but this section right now, we're going to be looking at section 8.4, quadratic equations of the form ax squared plus bx plus c. So a is highlighted here in the title to let you know that our a value won't necessarily be 1. So let's get started. Our vocabulary is really just one term, prime polynomial. These are polynomials that cannot be written as a product of two polynomials with rational coefficients. Basically, they're not factorable in the way that we've been working on factoring. So prime polynomials are prime polynomials that aren't factorable for all intents and purposes. All right, so let's get started. Here's our first example. Example 1, we are going to talk about factoring problems like this. Now, you remember, I think it was 2 lessons ago that we worked on factor by grouping. We're going to do some factoring by grouping in this way. Now, I'm going to tell you, because old people like to do this, I will tell you how we did it in my day. In my day, what we did is, we did not use marker, my friend. We did not use marker. Let me make sure I get that marker out of the way. All right, in my day, using a pencil, we would start off and you would think about all the numbers that multiply to give you 7x squared, because you remember before when x squared was alone, when it was just 1x squared or just x squared, we put x and x here, but not anymore. We'd have to put x and 1x here and maybe a 7 here. Since 7 can only be factored as 7 and 1, we'd do the 7 and then the 1, and then we'd keep guessing and put the 2 here and see if that worked. If that didn't work, we might try 1 and a 4. And if that didn't work, we do a 4 and a 1. And this is all well and good. It works perfectly fine. And it will be fine. We could do it totally fine. However, that's not what we're going to do today. What we're going to do is we're going to talk about another method where we're going to use factoring by grouping. So take a look at how we do it. The first thing you're going to do to use this method, because it's kind of foolproof, right? If you take 7 and 4, you multiply 7x squared times 4, and you get 28x squared. That's the first step. Then the next step is to rewrite the problem such that you are replacing 29x, right? Let me get that off. You're replacing 29x with the sum of two numbers that multiplies to give me 28, but adds up to give me 29. I know that sounds odd, but when I think about it, so after I multiply the A term, the complete A term and the complete C term, I will get this value, and then I'm going to look for two numbers that multiply to give me this 28x squared, but add up to give me 29. And I hope you guys kind of recognize it's got to be like 28x and x, okay? Because 28x and x will give me 29x if I add them up, right? So here's what I'm going to do. I'm going to write 7x squared plus 28x plus x plus 4. And now these are exactly the same. They're the same thing. But what we're going to do is now factor by grouping. All right. And I'm going to show you how we do that. Remember, factoring by grouping, you just kind of walking down the street, say, I'm not going to take you guys all on. I'm going to take 2 of you at a time. And so you're going to look at these first 2 terms and see if there's something that you can factor out of them. And when I look at these guys, I recognize 7 can be factored out of it nicely. And then also x, right? So I'm factoring a 7x out of these first 2 terms, and I'm left with x plus 4. Do you guys see that? 7x times x is 7x squared, and 7x times 4 will give me 28x. The next thing I'm going to do is see if there's something I can factor out of the next term so that I'm left with the same thing. Remember, the whole goal is to make sure and be left with the same thing. Well, we have the same thing. We have x plus 4. So what should I factor out? A plus 1. I think you knew that. So then if I factor out a positive 1, I really don't change the thing that I really am glad that I have, which is the x plus 4. So now, let's go back through what we did. We took this, we multiplied them together, we got the 28x squared. Then we had to ask ourselves, all right, we need to get that middle term. What 2 numbers do we multiply to get the 28x squared, add up to get that 29, and that's 28x plus x. So then we replace it. We see that this is exactly the same thing, but now we're going to attack it by factoring by grouping. So now that we've done that, we've factored out the 7x here, we factored out the 1, we've got this common factor of x plus 4. Factoring out the x plus 4, I guess I did need it highlighted, so I guess that's kind of okay. Factoring out this x plus 4 leaves us with 7x plus 1. and we have factored it. So here are two binomials that multiplied to give us this original trinomial. And thank you. Let's go ahead and try another one. So here, like I said, we can kind of do the guess and check method, but what we're going to do is do this method of multiplying the ax squared term and this 18, or the c term, and 18 times 3 is going to give me 8 times 3 is going to 4. What is this? 54? 54 x squared. So you got 54x squared. So the question is, what two numbers multiply to give me 54, but multiply to give me 54x squared, yet add up to give me 15x? So after thinking about it for some time, I realized that, oh, this is like one of my multiplication facts, right? 9x and 6x, and certainly they add up to give me 15x. So I do a rewrite. 3x squared plus 9x plus 6x plus 18. You might be wondering, well, would it change if I put the 6x here and the 9x? No, it wouldn't. It would be fine. It would eventually factor down to the same thing. We can try it if you want to, or you can pause me now and try it and see if you get the same thing I get. So I'm going to take these two terms and I'm going to factor out a 3x. When I do that, I'm left with x here plus 3. Do you guys see that? 3x times x is 3x squared, and 3x times 3 gives you 9. The next thing I'm going to do is factor over here. This is 6x plus 18. It actually looks like 6x h8, which looks very weird. I guess I should make that nicer. Do that and fix it up. So what are we going to factor out of those two terms? What are we going to factor out of these guys? Hopefully you realize it's a positive 6, and then I'm left with x plus 3. Exactly what I wanted, which is totally awesome. So now let's highlight that like that. So we've got those guys. I'm going to factor out the green stuff, or the x plus 3, and that's here. Once I've done that, I'm left with 3x plus 6. Can anybody see something else that I could have done? I should have done this earlier, but that's okay. We'll do it. So when I'm looking at this 3 and this 6, I'm like, ooh, more factoring could have happened, people. So I can actually say that this is equal to x plus 3. I'm keeping that part. I can factor out the 3 times x plus 2. Here's probably what I should have done. Let me go back up here. Usually I'm better about this, so I might actually delete this and do it again. But what I usually do is look to see if there's something I can factor out of all terms. And I could have done that. 3, 15, and 18 have a common factor of 3. So I could have simply done this. And if you saw this, bravo, pat yourself on the back. And then this would have been much simpler to factor because you don't have that wild coefficient or that non-1 coefficient there. So if we did that, we would have had 3. We would have factored it like we did when we had a is equal to 1, x over here, x over here. What two numbers multiply to give me 6, yet add up to give me 5? I think you're all thinking 2 and 3. And notice it's the same thing. So I will circle this guy over here, swoop, and circle this guy down here and tell you that they are the same thing. Little confusing? It's okay. It'll get better the more practice we do. Let's take a look at another example, please. So with this example, we're factoring with a minus sign here as this coefficient, the b is a negative, so we're going to have a slightly different situation. Let me do my due diligence. Is there anything that I can factor out of each term? No. So now I'm going to go back to my little method. I'm going to take 3x squared and multiply it by 20. When I do that, I get 60x squared. Okay, so that's what happened there. And then I'm going to take this 60x and see, are there two numbers that I can multiply together to give me a negative 17x? Well, if I have a positive 16x squared and I want to add two numbers up to give me a negative, you know both of those numbers must be negative, right? Because a negative times a negative is a positive. And then I can add those two negatives and get a negative. You see what I'm saying? You see it. I know you do. Okay, so let me get back to that. So we have this 60x squared, and we need to figure out two numbers that multiply to give me 60 yet add up to give me 17. And hopefully you can think about it and you realize that those two numbers would be 12 and 5. Remember, they have to have the same sign because we want them to give me a positive 60, but we want when we add them up to get a negative 17. So I'm dealing with negative 12x and a negative 5x. Will multiply to give me that and add up to give me that. Now I'm doing my rewrite portion and I'm writing things down so that I have equivalent equations here. So what I'm going to do is factor by grouping. What value can I take out of these two terms here? I can definitely take a 3 out. I can definitely take an x out. That means I'm left with an x here minus 4. and you can do distributive property to make sure you did a good job. The next thing I'm going to do over here, this is an X, looks like a Y, my bad. I'm going to factor a negative 5 out. When I do that, I'm left with X, and a negative 5 divided into a positive 20 is a negative 4. So beautiful things are happening. We see we got exactly what we wanted, which was the same thing here and the same thing here. I'm going to factor that out, and it'll be over here. Factor that out, I get X minus 4. Let's make that better. X minus 4 times what's left, the 3x and the minus 5. 3x minus 5. So x minus 4 times 3x minus 5 is the factored version of this. And as I look at it, I don't think I lost any factors. I don't think I misplaced anything. And I think we're good to go. Hopefully that makes sense. All right, let's take, if we have another fun one, prime polynomial. So if we were to try this and we had a situation where it was prime, and prime, we remember, means you cannot factor it, let's see what would happen. So I take my 4 and I take my 4x squared and I take my 5 and I get 20x squared. And then what I do is I'm now going to figure out what two numbers multiply to give me a positive 20x squared, yet add up to give me a negative 3. If it's going to multiply to give me a positive 20 and I need to add up to get something negative, I know both terms are going to be negative. But when I think about the list of possibilities, 5 and 4, 20 and 1, 10 and 2, none of these are working, because if I'm adding up a negative 5 and a negative 4, it's definitely going to be more negative than my negative 3x. So none of these work. So you'll find that you're hitting your head against the wall and you have to say, oh, it's prime, because nothing's working. So sometimes you can get prime ones, but make sure you've exhausted all of your choices before you say, oh, it's prime, I'm sure I can factor it. All right, so that happens. And let's look at this last example. Okay, I needed to get closer to explain this to you. So we're going to solve this equation by factoring. Suppose a cheetah leaps into the air with an initial velocity of 49 feet per second and lands on another animal 3 feet from the ground. How long will the cheetah be in the air? Or how long was the cheetah in the air? So in this problem, we need this equation. You will be supplied with this. This is a gravity equation, and this one is in feet per second. You may have seen in science negative 4.9. T squared, so forth and so on, and that one is meters per second, but this is feet per second because we're dealing with feet per second. And so let's talk about what everything means. H is the height at a particular time. T is the time in seconds. Time in seconds, that's the same T as this guy over here. They're the same variable. Right here, V naught or V sub 0 is the initial velocity. And finally, H naught or H sub 0 is the initial height. So basically what we need to do is use this information to fill in this equation and see what we got. We are looking for how long the cheetah was in the air from the ground to jumping on the back of this animal. So we realize that the time is what we're looking for, but the height is what we have. We know that the height of the cheetah at the time that we're talking about was 3. So I put a 3 there. Negative 16t squared plus, because we're looking for t, so that doesn't change. V naught or V sub 0 is going to be 49. So that was the initial velocity that animal was jumping, that the cheetah was jumping on another animal. My goodness, violence. T plus H naught. So where was he jumping from? Was he jumping from a tree? No, in this problem it seems like he's jumping from the ground, so the initial height is 0. So we notice that we have a quadratic equation. We're going to solve it, right? You know, when we solve quadratic equations, we move everything over to one side because we're setting it equal to 0. So I have 0 is equal to negative 16t squared plus 49t minus 3. You know what to do. We're going to multiply these terms together. I get a positive 48 t squared when I take these guys together. You know where I'm going with this. And when I do that, I recognize that I can simply get 48t times 48t times t is going to give me that, but when I add them together, I get what I need. Here's my rewrite. Let me do that. Did that to save time. Now I'm going to take these two and factor by grouping. Negative 16t squared and that 48 have a negative 16 in common and a t. And so when I do that, I'm left with t. This is going to be a positive t there, and this is going to be a negative 3. And you can see I've got plus t minus 3 again, so I'm going to do plus 1, factor out a 1, and I get t minus 3, almost taking it home. Negative 16t plus 1 and t minus 3 is what my factors look like. Wait for it. Don't forget that they're equal to 0. Set each equal to 0, which gives me that t can be 1/16 of a second or t can be 3.